College Algebra. Our notes today pick up where we left off from lesson 3.3. So yesterday we spent some time, if you'll recall, using synthetic division in our P over Q list to list all the zeros and find all the factors of a polynomial. Today you're essentially going to be working backwards. And so we start off with the fact that we use the fundamental theorem of algebra. So we talked a little bit about this yesterday, that the degree of the polynomial is going to tell you a few things. It's going to tell you the most number of zeros that you're going to have for the polynomial and the most number of factors. So for example, we have x to the third plus 3x squared plus 3x plus 1. The degree is 3, so I'm going to have at most 3 factors, at most 3 zeros. But what actually happens when you factor that down, you end up with x plus 1 to the third. So that's x plus 1 written 3 times. Essentially, you just have one factor. We say it has multiplicity 3, and you only have one zero, negative 1. All right, example 5. They're going to give you 1, 2, 3 zeros. They do tell you it's degree 3 in the directions, right here. And they do give you a point. Now, the reason why they're giving you this ordered pair is because your polynomial function could have been vertically stretched or shrunk. And we won't know that until we find out the a value, and I'll show you what that is. And we find that value based on using the ordered pair negative 1 and 6. Okay, the first thing you're going to do is you're going to just create a general polynomial. We're going to use x plus 3 for our 0 of negative 3, x plus 2 for our 0 of negative 2, and x minus 5 for our 0 here. Now, because this polynomial could have been stretched or shrunk, you will insert the letter a right there, and we will find that a here in just a little bit. The next thing you're going to do is you're going to spend a little bit of time multiplying this out. So I'm going to FOIL x plus 3 and x plus 2. And then I'll multiply that by x minus 5. Now, some of you really like grid multiplication, so that's the method I'm going to use over here. I'm going to put my trinomial across the top. Just like that. Then I'm going to do my multiplication. So x to the third, 5x squared, 6x, minus 5x squared, minus 25x, minus 30. When I total that up, I'll have x to the third, these add to 0, minus 19x minus 30. And we still have that a hanging around there. Okay, let me just double check my work real quick, make sure I'm solid. I don't want any mistakes. I left my answer key to your notes at school, so I'm just going off blind faith here that I've got everything correct. All right, that is step 1. What I'm going to do next is find this value for a. So I'm just going to move my work over here to my right margin, and basically what you're going to do is you're going to use this ordered pair to figure out a. It says we know y is 6 when x is negative 1. So I'm going to be putting negative 1 in for x. So I have 6 equals a, negative 1 to the third is negative 1, plus 19 minus 30. And let's see, what is that? That's going to be 18 minus 30, so negative 12. If I divide both sides by negative 12, I'll have negative 1/2. Okay, so to end our problem, we're going to go back and finish writing our polynomial. it is negative 1/2 for A, and then times x to the third minus 19x minus 30. So negative x to the third over 2 plus 19x over 2 plus 15. And that is your polynomial. All right, what you're going to need to do is pay attention to your directions. So I went ahead and multiplied it out only because I know with some of your directions it's going to say to find the polynomial with real coefficients. And what I have here is a polynomial with real coefficients. If you leave your answer not multiplied out, and you find A, that is in factored form. So watch your directions. Most of the time you'll be multiplying it out. All right, part B is a very similar question, except they word it just a little bit differently. They say 4 is a 0 with multiplicity 3. That means x minus 4 is a factor 3 times, so we cube it. We put our A right here, just like we did before. And we only put that in when they give us this extra ordered pair. And the ordered pair says when x is 2, our y is negative 24. And so what I'm going to do first is go ahead and multiply out my x minus 4 3 times. Oops. Okay, so again, I'm going to do some grid multiplication. Get that going. Let's use a different color here so it doesn't all blend together. Okay, let me double check. That looks good. All right, add up x to the third minus 12x squared plus 48x minus 64. All right, so we now have f of x equals a times x to the third minus 12x squared plus 48x minus 64. From here, we're going to plug in 6 and negative 1. So 6 is our y, negative 1 is our x, so negative 1 to the third minus 12 times negative 1 squared plus 48 times negative 1 minus 64. And we'll have a negative 1 minus 12 minus 48 minus 64. Oh my goodness, that's crazy. Okay, negative, let's see, what's that going to be? 48, 64, 13, 7, 15, 5, 11, 12, 125. I don't remember it being that crazy. Okay, let me go through and make sure I don't have a mistake somewhere. Oh, you know what? I put in the wrong ordered pair. I hope one of you guys caught that. I put in the same ordered pair from the first problem, so let me go back and fix that. I apologize. I'm making your video at about 8 in the morning, and I don't think I'm fully awake. So negative 24. Let's try this. A is 2, so x is 2. Got to use this ordered pair. So 8 minus 12 times 4 plus 48 times 2. All right, let's see what happens here. So we have negative 24. Okay. I knew something looked weird before, but I just wasn't awake enough to catch it. So negative 40 from these two. 96 minus 64 is, what, 28? Nope. How about not 28? Again, let's see. 96 minus 64 would be 32. All right, I think I'm awake now. So negative 40 and 32 would be negative 8. So A is 3. That looks a lot better. All right. So let's finish up here and let's take this and write our final equation. So we have 3 times x to the third minus 12x squared plus 48x minus 64, and then we will triple everything. 48 times 3, 144. 64 times 3, 192. Okay, there's your final polynomial. All right, so this part of the lesson is all about just going backwards. These problems will slow you down a little bit, and there's a little bit of work to show, as you can tell. When you do your practice problems down here, I did insert some directions. The 0 of 4 on number 12 is the one with multiplicity 2. The multiplicity 2 does not apply to both the 4 and the 2. It only applies to the 4. All right, let's see. Up here, find the zeros and their multiplicities. What you're going to want to do here on number 9 especially, when you're finding zeros, these need to be linear factors. So this is x squared minus 10. Think about that as difference of two squares. So this polynomial is the same as x plus 1 squared, x minus 1 cubed, x plus the square root of 10, and x minus the square root of 10. So think of that x squared minus 10 as difference of two squares, and the square root of 10 is what's showing up, because if I multiply these together, I'll get 10 back. So hopefully that makes sense. And then from here, you can tell me the zeros. Each factor produces a 0, and the exponent on the factor is the multiplicity. So just to get you going there, I'll show you like just a practice problem that's a little different. So extra problem, like numbers 9 and 10. If I had f of x equals x plus 2 to the 4th, x minus 3, let's even put an x out here for good measure, and then x plus the square root of 6, and x minus the square root of 6, and let's put a 2 on that one. All right, if I set each factor equal to 0, I will have, let's see, I'm going to even make a table. So this will be a two-way table, or a two-row table, I guess I should say. Okay, multiplicity. So if my 0 is 0, if I just have x hanging out front, that's a 0 of 0. Its multiplicity is 1 because it's x to the first. X plus 2 would be a 0 of negative 2, and its multiplicity is 4 because the exponent on it is 4. Then I would have a 0 of 3 with the multiplicity of 2, a negative radical 6 with a multiplicity of 1, and same with radical 6. So that's how I would tackle a problem like number 9 and 10. And then 11 and 12, you're going backwards from what we did yesterday. So 11 and 12 are covered in today's notes. Tomorrow's piece, we're going to finish out your notes with part D, and that's the end of the lesson. So like I said, this lesson is super long. We'll do this part on 311, so stay tuned. I won't be in class if we're in session, so there will be another video for this one.